Hi everybody, thanks for attending our presentation for this Site 2018 Las Vegas virtual presentation where we're going to talk about a course on leading computational thinking in K-12 contexts geared towards teachers and school librarians. We have some additional resources at this tiny URL location. My name is Kim Hewitt. I'm an assistant professor of instructional technology at the University of West Georgia, and my co-author is Bruce Neubauer, an associate professor of public affairs at Albany State University. And we're both designers of this course that we're about to tell you about. You can read the abstract if you like. You could pause the video and read it, but I'm going to continue on. We've got a roadmap, got 10 major areas we're going to talk about. These are divided up kind of along Morrison, Ross, Coleman, and Kemp's 2013 instructional design framework. We're going to start with instructional problems, or what are those needs or performance problems associated with our target learner audience? We will, by the way, kind of talk a little more about the learners and the context as well, but we're gonna briefly treat it here in the instructional problems section just to kind of make sense of you can't understand the need for the course Leading CT without also briefly understanding the audience. Okay, so we're going to talk about this course. I call it Leading CT from here on out for short. It's a graduate online course first offered in spring 2019 at the University of West Georgia. It's situated within an instructional technology program aligned to the ISTE standards for coaches. The audience for this course are school-based educators, including people in the role of teacher, K-12 teacher, and school librarian. But why? This still doesn't tell us why we need this course. So let me briefly explain the need. Briefly, in 2016, the ISTE standards for students were updated to include computational thinker. And arguably this is probably, I think, one of the most difficult of the new main areas of the ISTE standards for students. It's the most difficult to enact because of system-wide problems related to readiness. Are we ready to do this? So for me as a teacher educator, I ask, as teacher educators, how are we preparing in-service educators to guide K-12 students as computational thinkers? I think this is a good question. We see a lot of programs where people are kind of tackling this. So this is just one example of a course, my interpretation of how we can begin to tackle this given where we are in Georgia. Okay, so a couple of points from the operational definition of computational thinking from ISTE and CSTA. CT is a problem-solving process including formulating problems in a way that enables us to use a computer and other tools to help solve them, and generalizing and transferring this problem-solving process to a wide variety of problems. So CT is not necessarily something you need to know and do in a computing context. You can use CT across disciplines, which is why it is a good fit for K-12, but also CT is crossing professional disciplines. So students of today are more likely to encounter work in the future that requires that they have this problem-solving process, that they're able to use computers and other tools to help solve problems. They may not be headed to a computing field. They may not be a programmer of the future. They may be a humanities person, but everybody needs CT. I'm not going to go into this graph, but or this chart in too much detail, but the premise is that all students need some computational thinking, all K through 12. They need to be aware of it. They need to have access to the technology of this problem-solving approach of CT. There's a lot of really good reasons for that. I mentioned just a few in the previous slide. And some students need to be able to focus in more depth. Not everybody's going to head into computing. Not everybody's going to be a computer science professor or a software developer. But it's safe to say that most people are going to encounter it in their work, and then we're going to still need some people who are real specialists. So by introducing all students to it, you're making sure that all students are aware of this opportunity, this domain, so that we have a wider representation of students who actually do specialize as well. A couple of policy changes just to quickly mention in the Georgia context. So again, I teach teachers and school librarians in Georgia schools in an instructional technology program. But of interest in our policy landscape here, we recently saw a new draft, or a brand new draft, of K through 8 computing standards in Georgia from Georgia Department of Education. That's a big, that's kind of a big event. And it's clear that in order to do something with these standards, to use this opportunity, the hard work that went behind these, that school-based educators need to be ready. And so that's where our class comes in. I'd like to take a moment to say what Leading CT is not and what it kind of is. So what it is not a certification course that is designed to prepare students, or educators, excuse me, to teach computer science. That's not its purpose. We have an endorsement program in Georgia that's between 4 and 6 courses that students can take. They can then sit for a professional examination and they can get their computer science certification. That's not what this is, but this is designed maybe to show them the way to that if they're interested in it. This is also not designed to prepare people to enter the field of computing. So this is not going to get their skills ready, get them ready to be, programmers or, a database expert. That's not what we're doing in this class either. What it is it's designed to familiarize educators about the value of computing for all students. It's designed to equip educators with tools and strategies to support K-12 learning with computational thinking. And it's designed to support educators in determining their roles in relation to the innovation of computing in schools. And that goes back to the ISTE standards for coaches, which, like the first ISTE standard for coaches has to do with vision, the vision of a school. And so, coaches are people who can lead in their schools, whether they're in a classroom or they're in a school library. They are leaders in the school. They have vision. So this course is partly here to help them to expand their vision, particularly as related to computational thinking. Let's look at learner characteristics and contextual analysis. So the learner characteristics deal with relevant features of learners that may impact learning, and the contextual analysis involves the nature of the learning environment. And I've already said some of this, so this shouldn't take too long. So our learners are in-service P12, K-12 teachers and school librarians. They're full-time employed. They're seeking a master's or specialist degree in instructional technology. They're geographically spread across the state of Georgia and beyond, and we can assume they're usually familiar with K-12 schools, pedagogies, policy, and other issues. The learning context is a public university, 100% online course, taught during a 16-week semester, and it's mostly asynchronously taught, has asynchronous, mostly individual projects with optional synchronous meetings. Instructional strategies involve ways of presenting information that help the learners to engage with the instruction. And this first one is kind of, I guess this is sort of an instructional strategy. And it's related to this idea of skepticism. I want my students to be skeptical of the innovation of computer science, education, of computational thinking for all K-12. I need them to be skeptical, and I want them to use this course to gather evidence that supports this reform. I do not want them to just believe me that it's important. So I want them to explore throughout this class. I want them to explore this innovation and think about how they're related to it. So here are the big questions that I'm trying to get them to consider throughout the course. What do I think about the reform? I'm calling it a reform. You can call it an innovation, but this diffusion of computational thinking in schools, what do I think about it based on readings? Who are my stakeholders and which of them are likely to be affected by it? What is my current and future role in relation to the reform of computational thinking in all K-12? And what further professional learning opportunities do I need to facilitate my role in relation to the reform? So I have them thinking, who are they? What is their current and future role? And what do they need to do to further their knowledge and skill related to it? It is experience that has taught me to take that approach with my students because I find them to be very eager to adopt technology unquestioningly, and I need them to be skeptical because we don't want to just usher in new technologies unless we have a really good understanding of what they might actually do to help. So that's part of what they're doing here. They're gathering, through this course, they're gathering information and understanding related to this reform and why it's worthy of their time and attention. So again, we're not even going to believe ISTE that it's important. We're going to explore it thoroughly, and I think a lot of them will find it to be, compelling. So other instructional strategies as I attempt to make the course relevant. That's how I do that by having them position themselves, by having them identify who their target audience is. So all of their projects are kind of tailored towards their target audience or their potential target audiences. I'm also learning alongside them, that I make that very clear that I am interested in learning about this topic, and I am going through professional development in the same area at the same time. I'm researching in this space, but I try to make that really transparent for them because I think that that's a sort of a motivational strategy. I allow them to revise work towards mastery, and I definitely use the personalization principle a lot in the written materials of the course. So we use a lot of second person in how we design the course. This is not really a Morrison, Ross, Kalman, and Kemp aspect of the instructional design model, but I do want to take a second to read you the course description. The course focuses on selecting, developing, implementing, and leading educational initiatives focused on developing K-12 learners' knowledge and skills in computational thinking. Coursework focuses on exploring issues related to broadening access to computing in schools. The audiences who will most benefit from the course are K-12 educators and school librarians. So that kind of emerges from what I just told you about how they need to be addressing these big questions throughout the program. Okay, so let's look at instructional objectives and task analysis. I'm going to actually go ahead and carry you through the 8 course objectives and kind of explain some of the, very briefly, the tasks they do to fulfill those objectives. So instructional objectives are what the learner should know and be able to do as a result of instruction, and the task analysis is the detailing of the content and procedures necessary for learner mastery of objectives. So objective number 1, define computational thinking. They do this through an introductory discussion on CT. And other course projects build on this, but I think it's a very core objective to the course. Objective number 2, explain the traditional barriers to computing careers for females and minorities and highlight strategies for overcoming them. They write several short papers focusing on these topics. They are going to create a learning plan where they plan accordingly for females and minorities in their class and how to ensure that they are being culturally responsive. And they have an elevator speech that they're going to give, which demonstrates their understandings of systemic barriers of access. Course objective 3, identify resources for supporting learning of computational thinking in K-12 or informal learning contexts. This is where they go and gather curricula, pedagogical resources, free tools, and professional learning networks to support their efforts to lead CT within their respective roles. Objective 4, explore professional learning networks, communities, or resources to support continued professional growth as an advocate of computational thinking for K-12 aged learners. Same as 3, this is really an extension of 3. I say advocate, and I guess that's dangerous because it sounds like I'm telling them they should be an advocate, but they really don't have to be. I make that clear, but I do want them to, this is sort of assuming if they do advocate for it, what are those networks, communities, etc., that they can use. Objective 5, analyze I have a tricky mouse. Analyze computing innovations in terms of their social, economic, and cultural impacts, both beneficial and harmful. They create a discussion prompt for their third discussion in the class, where they, after they've kind of learned about the APCS principles and the big idea of those, the big idea from those principles related to impact on society. So they construct an impact on society discussion prompt related to privacy. They also build on that work in short paper 3. Objective number 6, demonstrate effective planning for the instructional design, facilitation, and/or classroom management of computational thinking activities among students or teachers in K-12 or informal learning contexts. So the major tasks associated with Objective 6 include the learning plan, which I mentioned previously. The students may plan the integration of computational thinking into a classroom grade level school or after school program. The elevator speech also provides a place where learners can talk about the guiding vision behind their plan. They do talk about sort of a context of interest to them, of relevance, and their job in that speech is to convince their listener that this is important and, that it's necessary. Objective 7, given that computing is a way to express creativity, solve problems, enable communication, and foster innovation in a variety of fields and careers, defend a rationale for the importance of K-12 learners' development of knowledge and skill in computational thinking. They do this again through the elevator speech, which includes some pre-writing as well, and they're going to share this in a discussion board where they can kind of react to one another's elevator speeches. So again, when I tell them to do this, to defend a rationale, I also remind them that they may not actually agree with the innovation of CT yet. They're not through the whole course, and it could be when they arrive at the end that they don't want to have anything to do with it in their K-12 context. But I'm not finding that to be the case during the first implementation of the course. I find people to they seem to be indicating their eyes are being opened by something they weren't quite aware of. But still, when they're defending the rationale, they're just practicing taking a side. So they're going to have a pro CT stance here, and they're going to practice doing that, and they're going to throw everything they've been learning in this course at it, and they're going to express it in a really brief, punchy elevator speech video. And finally, objective number 8, create computational artifacts that demonstrate development of knowledge and skills related to decomposition, pattern recognition, abstraction, and/or algorithm design. So what they do here is they do about 30% of the course involves time on task working on the creation of computational artifacts, which can include things like programming in Scratch or doing activities on code.org. And there's a lot of other sites, and I've got a document that I've created with about 50 options for things that they can work on for this, but this is in an ongoing fashion. They journal about it. They journal very briefly about what they worked on and which of the parts of the definition of computational thinking their activities hit on. So it's kind of open-ended here during the first enactment of the course. I'm a little torn as I've designed the class as to whether this should be strictly predefined or open like other things are, because they're all in different contexts. There's different things that if you're in middle grades, you may not want to learn about the code.org curriculum for early childhood students. You might want to learn about how to use Alice or a variety of other tools. If you're in the high school setting, you might want to learn more about high school level tools, or even tools that would take students towards college. So I am open in how we interpret this, but I just tell them that they need to demonstrate significant time on task towards these computational artifacts. In terms of evaluation approaches, those tools that we use to assess the performance of learners, we use a lot of instructional guidelines. So I'm currently not grading everything by rubric, because in the first iteration of the course, you're trying to be responsive to the needs of the students. It could be that when you first develop a course that it doesn't quite make sense. And so we provide guidelines. I provide an example. So as you can see, there's an e-portfolio that students have. And I'm providing them an example of how that e-portfolio could look, modeling how you can design it and the types of things that you can consider when you're setting goals related to your role within computational thinking. So I provide examples. I allow them to revise their work. So any work that they do, I provide qualitative feedback on it, and then I'll return that work to them, and then they can revise that further. So it's kind of I think it's a pretty safe space for them to kind of learn and not fixate so much on grades and taking risks. I want them to take risks in this class, and I want it to be okay for them to not be perfect the first time they submit something. And I have noticed, this is not probably part of this presentation, but just anecdotally, I have noticed a bit of frustration and some intimidation among some of the students. So I think that's an important approach to allow that revision of work. I'm also collecting feedback surveys throughout the course, just kind of asking them, how are things going? What are you enjoying? What are the challenges you're facing at this point in the course? And I'll be using those, really for the next iteration of the course. It's not really feedback. I have used the first 2 feedback surveys actually to adapt the current design, the current semester, but at this point I'm done taking feedback. I can't take any more. I just need to deliver the course as designed, and then we're going to check those latter day feedback surveys as well for that future iteration of the course. Okay, in terms of content sequencing, the order in which the instruction is presented to the learner, in an ongoing fashion, they are working on reading journals to trace big ideas. They always have a number of readings every session related to the different course topics. They've got computational activities in an ongoing fashion across the course. Then they've got short papers that kind of come in every other sort of big session, so sessions 2 weeks. So every other session, they'll have a short paper that they write kind of in the middle of the class. We have discussions also at regular intervals, not every session, but every other session, sort of alternating with those short papers. I'm just trying to kind of give you the rhythm of the class. The course plan is in the folder at tinyurl.com/site19leadct. And actually, at the end of this presentation, time allowing, I will show you I will show you the course plan, and I will show you I may even hop into the course really quickly. That's if you have time, you want to see, something else. All right, designing the message. This is the rhetorical approach used in addressing the learner in the graphical, textual, and typographical design of messages. I use checklists, welcome page with a video walkthrough of the whole session. There are 8 sessions, by the way, so every time there's a new session, I call them a session. You might use the word module if you're talking about an online class. I don't like that word. So we call them sessions. So every session has a welcome page. It's got a video walkthrough. It's got the learning objectives. It reminds them of, here's the syllabus, here's the big picture course plan. And then the session activities page gives them all of the, an overview of all of the things they're doing specifically in that session. And then it branches out into several sub-pages, the readings page and the computational activities page. The readings page kind of carries them through a number of readings, usually around a theme, that support things like those short papers. So how do you prepare someone to talk about barriers to computational thinking and computer science education for minority students? What kind of readings do you have to do for that? Well, that's what the readings page is doing. It's showing them reports and research articles and educational programs that have been created to address these kinds of things. So they have a variety of readings, usually at least 10 readings per session. A lot of them are really brief. Like, for example, I'll make them read the executive summary of a big report. I'm not going to make them read 10, huge things, because I do want them to focus. Computational activities, again, is another subpage. In addition to just telling them to work on computational activities, I also include some basic computer science related terminology. Like one session we looked at the concept of the algorithm and watched a couple of supportive videos on that. Another session we looked at the concept of abstraction, and then we watched maybe one video kind of going into depth on what abstraction is. So I not only say go do your computational activities, but I also say, why don't we take a moment to look at this computational concept a little more closely. This class is not going to teach them everything about computer science. That would not be possible given where they are. That's a different class, but it is here to kind of let them really get their feet wet. Of course, I try to use accessible, consistent design in my courses, use of headings on the HTML pages, use of alt tags, with images, and I use APA throughout the class. It's kind of a new thing for me even. I've had a more casual approach to presenting readings, but now I'm trying to use APA more. I'm trying to model it because I expect them to do the same. So that's another part of designing the message. Development of instruction involves the development of web pages, the documents, the instructions that form the basis of instruction. This course has been developed in D2L Brightspace, but projects and project instructions, guidelines, lots of the resources are in Google Docs to allow for rapid revision in response to needs. Future work involves evaluation of what we did this semester, looking at student evaluations, quality of student work. Did students really meet these objectives that I wanted? Did they really do a good job in their computational artifacts, or were they kind of allowed to drift away from whatever I had in mind? So we're going to evaluate this class. We're going to look at those student evaluations. We're going to look at their feedback throughout the course. But in addition, I'm going to invite, if you're interested in actually poking around the course and looking inside of it and doing an informal-ish evaluation that I don't think should take more than about 45 minutes, I would love for you to do that. You can email me at khewitt@westguy.edu. I will be doing that in the summer of 2019. We'll be taking in those kinds of evaluations. I'm going to ask folks in my instructional technology department and school librarians that I work with to also do that. And then we will have a second teaching of the course in spring of 2020. So if you have questions or comments, feel free to email me at khewitt@westguy.edu. And don't forget, we've got a few resources at tinyurl.com/site19leadct. And very quickly, here's our references page. I'm going to now take the rest of this video. You can sign off. Thank you for coming. You can sign off, or you can hang around. I'm going to show you a couple things. So if you go to tinyurl.com/site19leadct, it takes you to a Google Drive folder. And right now, currently, at the time of making the video, it only has one item. But this one item can take you to some things that you can learn more about the course with. So this is the course plan, my favorite document in the class. And notice you can, from here, jump over to the syllabus, and you can see, kind of what we're doing during each session. So you've got the session sort of temporal boundaries over here. You've got readings and meetings. You've got, in this final column, you've got what we're actually doing for course credit, or things like the feedback surveys that I was talking about. You can see all of these projects. You can learn more about them. You can kind of ignore some of this extra stuff, right? And these I'm actually going to delete that so that y'all don't have to worry about that. But here under course assignments, you can go in and actually look at the instructions I'm using for the various papers. So that's really the main thing. You can kind of see a lot of the course that way. Let me go ahead and show you one session module inside of the course. So let's take a look at session 2. Access to CS. This is the one where we focus on female access. We talk about algorithms and CS fundamentals. So we're going to go into session 2 of the course and take a look. Okay, so we're in the course homepage. I'm going to go into the content and take a quick look at session 2. We start with the checklist, kind of telling them what all they need to do that session. I talked to you about the welcome page. Here they can watch. I actually have 2 welcome videos in this session, kind of walking them through the session. Module objectives, the course plan and syllabus. I added this additional sort of introducing session 2 activities. I probably do this more because I'm teaching the class for the first time and I'm confused, and I want to make sure that they're not confused. It's really probably not necessary. So then I give them an overview of their session 2 activities. That includes in this case, they're continuing working on their reading journal. So they have session 2 readings on the next page. We can look at those in a second. They have a short paper in this session. They've got instructions, and then they submit it to a Dropbox. And then they've got computational activities, which I want them to submit in 3 batches. So during session 2, they submit their first sort of batch, their 2-session batch of computational activities they've been working on that they post to their website. And they can go look at the session 2 computational activities page to further see some other activities. So like on readings, you see a number of readings. I like to start with the video, but lots of different reports and things, and they report on this on their reading journal. And computational activities allow them to learn about applications